Good day, viewers. This is 300 Plus Academy, where all we do is exams tutoring, ensuring that you ace and do well in your next exams. Of course, moving into the beautiful subject of chemistry, what we'll be dealing with today is stoichiometry, as it involves chemical equations. We want to take those calculations that involves chemical equations, talking about the mole via what I call key door concept. I haven't talked about mole concept and Avogadro's number before. Of course, the link to that lecture video is in the description of this lecture. Okay, I haven't looked at mole concept before. We've been able to establish, okay, we know mole equals to mass over molar mass, and we also know that number of particles equals to mole times Avogadro's number. From this, we can say that mole equals to number of particles divided by Avogadro's number, and will be correct, so that we move away from the conventional mole equals to mass over molar mass, and we begin to deal with other parameters as it relates to mole. Now let's quickly talk about concentration, and the reason why we'll be talking about concentration is simply because in stoichiometry, whatever parameters we are given in our question, look at, like in this case, we're given 9.03 times 10 raised to the power 22 molecules. But before we can proceed with this, we have to convert it to mole. Here we're given 10 kilogram of iron. Before we can proceed with this, we have to convert to mole. There are questions where we'll be given concentration, so we have to know how to navigate and convert things to mole. So when we say concentration, what does concentration mean? Concentration. Okay, concentration written as C. Okay, let's talk this time in mole per dm³. We are simply, when we talk about concentration, it is the number of moles of particles dissolved in 1 dm³ of a solution. In this case, that means mole dissolved in 1 dm³, of a solution. So when we say concentration, it is the mole per unit volume of a solution. Let me put that down and explain things in ordinary conversation. Let's assume we have a solution this way, and let this be 3 dm³, or what we call 3 liters. It means the same thing. If I am to dissolve 6 moles of glucose into this solution, if I'm to dissolve 6 moles of glucose into this solution, what that simply means is more or less like I want to say, okay, let this be 1 dm³, 1 dm³, 1 dm³, and I am distributing 6 moles equally into 3 places, so 6 mole. So that here is going to mean 2 moles per dm³. In other words, 2 moles goes to each liter of this solution, to each dm³ of this solution, and that is why we do say concentration here means moles divided by the volume of the solution in dm³. If I work based on this, so it means that I can say concentration, this concentration here is going to be mole per dm³, and that is going to mean number of moles that I have divided by my volume in dm³, and I'll be correct. So this concentration in mole per dm³ is what I call my molarity, or concentration in mole per dm³, molarity, or you call it molar concentration. That is what I just described now. So that what this means is that if I am given concentration and I know the volume, then I can make mole the subject, and the implication of that is that mole equals to concentration in mole per dm³ times volume in dm cube, written simply as C times V. So, and I'll be correct because what I've just done is that I've been able to convert concentration and volume to mole, that is talking about molar concentration. Worthy to note that, okay, sometimes my volume can be in cm cube. So what that means is that concentration equals to mole divided by my volume in cm cube. But we all know that 1,000 cm cubes makes a dm cube or a liter. 1,000 cm cube makes 1 dm cube or a liter. So that if you move from cm cube to dm cube, you divide by 1,000. If you move from dm cube or liter to cm cube, you multiply by 1,000. The implication of that is if I have my volume in cm cube, for me to convert volume in cm cube to dm cube, I have to divide by 1,000. And what that now means is that my concentration in mole per dm cube is going to be mole times the 1,000 goes up divided by volume in cm cube. And this here is what we are going to have and would still be correct talking about molar concentration. As we talk in molar concentration, sometimes our concentration can be in gram per dm cube. So what that means is that concentration in gram per dm cube, or what we call mass concentration, is amount of substance in mass divided by the volume in dm cube, and will be good to go. So knowing how to navigate, from concentration to mole is very central, and knowing how to navigate from number of particles to mole, and they are all central into dealing very well with stoichiometry. Also, let's quickly talk about what we call mass volume relationship as it relates to gas. When we talk solid reactants, we do say mole equals to mass over molar mass. In this case, we're talking mass. When we talk about gases, and this one here, molar mass is the mass of 1 mole of substances. Of course, when we're dealing with gas, you need to understand that there's what we call molar volume. There's what we call gas molar volume, that's GMV. This is the volume occupied by, that's the volume, that's the space. That's the space occupied by 1 mole of just about any gas. Occupied by 1 mole of a gas, and this the volume occupied by 1 mole of a gas molar volume is actually 22.4 dm cube, or you call it 22.4 liters, or you say 22,400 cm cube. That's if you're converting from dm cube. So that is gas molar volume. That is the space occupied by 1 mole of a gas. The implication of this is that just like you're saying mole equals to mass over molar mass, in terms of volume, mole equals to volume of a gas divided by the molar volume. Because here you're saying mass of that substance divided by mass of 1 mole of the substance to get your mole. When we're dealing a volume of gases, it is always volume of that gas divided by the volume of 1 mole of that gas. That's called molar volume. I can put that as a mole equals to V over mV, and I'll be correct. So which means that if I come here, I can as well say, when I'm looking for my mole and I'm given volume, I can convert that volume into mole. That is the implication. Also, talking about what we call mass volume relationship, talking about mass volume relationship, you just said mole equals to volume over molar volume. Mole is what? Mass over molar mass, and that is equals to volume over molar volume, gas molar volume. The implication is that I could navigate from mass to volume and I could navigate from volume to mass. This is what we call mass volume relationship. Having said all of this, it is about time we get into solving questions. So moving on, we have some questions to attempt here. The first question says, calculate the mass of ammonia required to produce 9.03 times 10 raised to the power 22 molecules of nitrogen according to the following equation. In this regard, we've been given the equation. So what we have is 4NH3 plus 3O2 plus, to give us 2N2 plus 6H2O. In this case, we were told that calculate the mass of ammonia. So which means we are looking for the mass of ammonia. That is the question. To produce 9.03 times 10 raised to the power 22 molecules of nitrogen. This was what was produced, and the number of particles, the number of molecules of nitrogen produced, N equals to 9.03 times 10 raised to the power 22 molecules. That is exactly what was produced according to the following equation. That was all we were given. Now, how we approach this is very simple. This that we were given information about, this here is our key. This is our key. This that we are to look for, this that we are to find, becomes our door, and that's why I call this key door concept. I will be using this to unlock this, because from the question I was given information about nitrogen and I was told to look for the mass of ammonia. Now, this is my key. What I am going to always do to my key first is to convert whatever it is I am given, to convert it to mole. We all know that number of particles equals to mole times Avogadro's number. Therefore, mole equals to number of particles divided by L. In this case, this means my mole equals to 9.03 times 10 raised to the power 22 divided by 6.02, which is a constant, of course, we were given in the question, times 10 raised to the power 23. Times 10 raised to the power 23. 9.03 divided by 6.02 will give us 1.5 times 10 raised to the power 22 minus 23. That means 1.5 times 10 raised to the power minus 1, and this means 0.15 mole. That is what I have. So what I have done now is that, working on my key, I have converted it to mole. That is the standard procedure. You convert whatever key you have to mole. Now that I have done that, I am going to use this to unlock this door here. So this is my key, this is my door, and that is what stoichiometry is all about. Whatever it is you're given information about, use that information, convert it into mole, use that mole to unlock or find whatever you are looking for. So in this case, according to a balanced equation like we have in this situation, 2 moles of nitrogen gas is stoichiometrically equivalent to 4 moles of ammonia. So what that means is that I'm going to equate. So I'm saying 2 moles of nitrogen gas is stoichiometrically equivalent to 4 moles of ammonia. So what that means is that from equation, if I'm saying 2 divided by 4, 2 divided by 4, it means number of moles of nitrogen from the equation divided by 4 moles of ammonia. In actual sense, I actually have 0.15 mole of nitrogen in reality. So if nitrogen was up on this side, nitrogen should also be the numerator on this side. 0.15 mole divided by mole of ammonia. So what that means is that this will move here, so that my mole of ammonia will be 4 times 0.15 mole divided by 2, and that is going to give me 0.30 mole. So it means that the mole of ammonia here is 0.30 mole. But I was not told to look for the mole. I was told to look for the mass. So look at the process again. You identify your key. Once you identify your key, you convert your key to mole. Once you've converted your key to mole, you then use that mole to find the mole of whatever you're told to look for. That's, you use that key to open this door. When you've done that, you can then convert your mole into whatever they are asking you here. In this case, I was told to look for the mass of ammonia, and we all know that mole equals to mass over molar mass. Therefore, mass equals to mole times molar mass. In this case, that is 0.30 times, what is the molar mass of ammonia? That is 17. Take note, I am not using the 4 in this case again because I had already equated it here. So 0.30 times 17, that's going to give me 5.1 gram. That is the number of moles of, so that is the mass in gram. Look at it, calculate the mass of ammonia. Mass of ammonia here is 5.1 gram. And with this, I'll be correct. Look at the process again. Identify your key, convert your key to mole, use your mole to unlock the mole of whatever you're looking for, convert that mole into whatever the question wants you to do. Imagine this question wants me to calculate a number of molecules here. Imagine this question wants me to calculate number of molecules. Number of molecules, N, is going to be mole times Avogadro's number. So number of molecules is going to be, I have 0.30 times 6.02 times 10 raised to power 23. So that's going to give me 1.806 times 10 raised to power 23 molecules. In this question, I can be told to look for, imagine I'm being told to look for the volume of oxygen gas. So long as I have my key, I can always look for that very easily. Okay, let me try to do that. Imagine I am being told to look for the volume of oxygen gas in this regard. Since I already have my key, it is a very simple thing. This is a mole. I then need to unlock the mole of this. So how I'm going to go about this is that I'll be saying 2 mole of my nitrogen gas is equivalent to 3 mole of my oxygen gas. So if I'm saying 2/3, it means I'm saying 2 divided by 3, then mole of this, which is 0.15 mole, divided by the mole of oxygen. So that the mole of oxygen this time is going to be 3 times 0.15 divided by 2. And that is going to, mole of oxygen here, mole of oxygen is going to give me 0.225 mole. 0.225 mole of oxygen is going to be 0.225 mole. But I was told to look for the volume of oxygen now. So we recall that I told you mass volume relationship where I said mole equals to volume over molar volume. Molar volume is a constant, which is 22.4 dm³. Therefore, my volume is going to be mole times molar volume. So my volume here is going to be 0.225 times 22.4 dm³. So 0.225 times 22.4 dm³ is going to give me 5.04 dm³. So according to this equation, based on this equation, it simply means that the volume of oxygen that will react with this ammonia to give me this product is 5.04 dm³. So it's just about you knowing how to navigate. Knowing the formula to use is one thing, knowing how to navigate is another thing. But don't forget, stoichiometry is what we're dealing with, which I call key dot concept. Whenever you're given a question, try to identify the key. That is talking about which of the reactants or the product were you given information about convert that information into mole, convert that value into mole, then use that mole to unlock the mole of what you're trying to look for. Then when you've done that, convert that mole into whatever they want. If they want the answer in mole, you leave it as mole and you're done. But if they want it, let's say in mass, in volume, in whatever they want, in number of particles, then from mole you can convert to whatever the question wants you to do. It's a pretty direct stuff. Moving on to question 2, it says iron 3 oxide to combine with carbon 2 oxide to give, according to that equation, okay, you have Fe2O3 plus 3 moles of carbon 2 oxide to give you 2 moles of iron plus 3 moles of carbon 4 oxide. So how do we go about this? We were told, given the equation, but of course, when you get to that level where you're just given question and you have to write your equation by yourself, the implication of that is if you don't know how to write equation, there is going to be a lot of issues as far as stoichiometry is concerned, because once you don't get your equation correctly, once your equation is not balanced, it then means that everything you're going to do is going to be wrong, because there is no way you will be able to equate correctly if the coefficients of all of the reactants and the products, if they are not, if they don't correlate, if they do not balance up, then every other thing you calculate is going to be wrong. So subsequently, we are going to learn about how to write balanced chemical equation. Okay, let's continue with question 2. So this is what we have. They said, what mass of Fe2O3? So what mass of this? So this becomes what I'm looking for. This becomes my door once again, and produce 10 kilogram of iron. So mass of iron produced is 10 kilogram. Of course, this becomes my key without being told. I know that I'm to use this to unlock this. But mind you, in physics, according to the SI units, we deal in kilogram. In chemistry, we deal in grams. So this has to be taken to gram so that the mass is 10,000 gram. You know, to convert kilogram to gram, you multiply by 1,000. Now that I have this, now I have to convert it to mole. My mole equals to mass over molar mass. So in this case, that is going to mean the 10,000 divided by, what is the, for iron is 56. So 56. This should give me 178.6 mole. I have just converted my iron there into a mole. I can then use this to unlock this. So what this means here is 2 moles of iron is equivalent to 1 mole of iron 3 oxide. So I'll say 2 mole of iron is stoichiometrically equivalent to 1 mole of Fe2O3. That's iron 3 oxide. So if I'm saying 2 over 1, from the equation, 2 divided by 1 equals to mole of this divided by the mole of this. So that what I have is 178.6 mole divided by mole of Fe2O3. Mole of Fe2O3, one we move here, that's 178.6 mole times 1 divided by 2, we come here 2. So mole of Fe2O3 is 89.3 mole. That is the mole of iron 3 oxide. But the iron 3 oxide, I was not told to look for mole, I was told to look for mass. Then I would have to convert this mole into mass, so that the mass of Fe2O3 should be mole times molar mass. So what I have is 89.3 times Fe2O3, if you are to calculate that, that should give you 160. If you don't know how to calculate relative molecular mass or formula mass, you can, of course, go to the description of this lecture video. You will see how to calculate relative molecular mass, percentage composition, empirical formula, and molecular formula as well. So what you have here is 89.3 times 160, 185, 14,285.7 gram. This is our answer, or we can convert to kilogram. That would be 14.2857 kilogram, and that way will be correct. It's actually not very difficult. Locate your key, convert it to mole, use that mole to unlock the door, and find the mole of that door. When you get the mole of that door, if they want the answer in mole, that is the end. If they want it maybe in mass, in volume, in number of particles, then you convert the mole to exactly what the question wants. It is a very direct process. So that ends this particular question. But let's imagine that here we were told to look for the number. We're told to look for the number of particles of carbon dioxide from number of molecules of carbon dioxide. If I was told to look for the number of molecules of carbon dioxide, there is also a way as to how I'm going to deal with things. If I'm told to look for the number of molecules of carbon dioxide, yeah, it's a very simple thing. This is my key. I should be saying 2 mole of Fe is stoichiometrically equivalent to 3 mole CO2. So that means if I'm saying 2 over 3, it means I'm putting the mole of my iron up. What is the mole of my iron? 178.6 divided by what is the mole of my carbon dioxide. So mole of my carbon dioxide is going to be 3 times 178.6 divided by 2. So that it's going to be 267.9 mole. Of course, I am not told to calculate the mole of carbon dioxide. I am told to look for the number of particles, and you know the number of particles is actually mole times Avogadro's number. So that is 267.9 times 6.02 times 10 raised to power 23. So look at this. Look at this. 267.9 times 6.02. That is 1612.76 times 10 raised to power 23. Of course, this must be in standard form. When I shift my decimal point backward, that is close to the index. So I'm going to move this 1, 2, 3. 1. This is going to be 1.613 times 10 raised to power. This was 23, and I shifted 1, 2, 3. 26 molecules. So that is the number of molecules of carbon dioxide, if that is what I was told to look for. Recall the process again. The process is very direct, and it is that identify your key, convert your key to mole, which is a standard key now. Use that to unlock whatever it is you're looking for. But of course, in unlocking, you're going to get that in mole. If the answer is wanted in mole, you leave it that way. If the question is asking you mass, number of particles, volume, then convert the mole into those and you'd be good. Now, very quickly, let's move to question 3 so that you see that when you deal in stoichiometry, it is a must identify your key. It doesn't matter what you're given about your key. You have to just convert it to mole, then use that to get the mole of what you're looking for and convert into whatever you want. So this third question states a volume of 10 cm cube was phosphorus trichloride, density 1.5 0.74 gram per cm cube react with water according to the following equation. So we have PCl3 reacting with water 3H2O to give us phosphorus hydroxide POH3 plus 3 moles of hydrochloric acid. Okay, in this case we were told 10 cm cube of phosphorus trichloride. This is my phosphorus trichloride. The volume was 10 cm cube, and we were also given the density. We were given the density in that bracket. So what you have is 1.574 gram per cm cube. So this is my key because I have information, I have values about phosphorus trichloride, and I was now told to look for the mass of HCl produced. I'm looking for the mass of HCl produced here. That is the question. So invariably this becomes my key and this becomes my door here. So I am to use this to unlock this. Also, what mass of water is required for the reaction? Okay, I was also told to look for the mass of water. Okay, this is also a door as well. So I am going to use this to unlock this and then this. So let's move on. So this is my key. The first thing is to try to convert to mole. And in converting to mole, you recall that density equals to mass over volume. And invariably that now means that mass equals to density times volume. Mass equals to density times volume. The implication of that is that the mass here is, the density is 1.574 times 10. So the mass here is 15.74 gram. I've been able to get the mass, but I cannot use the mass. I still have to convert the mass to mole. So the mole of my phosphorus trichloride is going to be mass over molar mass. In this case, the mass is 15.74. What is the molecular mass of phosphorus trichloride? It's 137.5. Calculating this. So 15.74 divided by this will give us 0.114 mole. So that is the mole of phosphorus trichloride, showing you that I have worked on my key and I've been able to convert it to mole. Now that I have done that, it should be very easy for me to unlock this. So in trying to unlock this, this is what I am going to have. I should be saying 1 mole PCl. Okay, let me do this way. 1 mole PCl3 is equivalent to 3 mole of HCl, so that if I say 1/3, that's 1/3, then it should be mole of PCl3 0.114 divided by mole of HCl, and in that case the mole of HCl is going to be 3 times 0.114 mole, and that should give me 0.342 mole. But I was not told to look for the mole, I was told to look for the mass. So mass of HCl is going to be mole times molar mass. The mole is 0.342 times, what is the molar mass? HCl is 36.5. And that is going to give me 12.48 gram. Yes, 12.48 gram. And that is very direct. I've been able to get the mass. So I was supposed to look for the mass of water. If I am to look for the mass of water and I go the same way, I want to use this to unlock this water that I have here, then what that will mean is 1 mole PCl3 is stoichiometrically equivalent to 3 moles of water. So saying 1/3 equals to 0.114 mole. divided by mole of water. Mole of water comes here. So my mole of water is still the same thing as 3 times 0.114 mole. And that way, mole of water will give me 0.342 mole. Since I was told to look for since I was told to look for the mass of water here, then the mass of water is going to be mole times molar mass. So mole times molar mass here is going to be 0.342 times 18. Molar mass of water is 18. That will give you 6.16 grams. 6.16 grams. So that is how stoichiometry, that Skido concept, works. But in this case, recall that we did not write any equation by ourselves. The equation has been given. So what happens when we have to write the equations by ourselves? What happens when we are given concentration? What happens when we are given impure substances? What happens when we're told to calculate percentage impurity? All of these and many more are what you're going to see in the part B of stoichiometry. This is just part A, introducing you to the concept. That is why I said Kido concept. Now that you know what to do and what to expect, in the next lecture, what we are going to be looking at are questions where we have to write the equations by our own selves. We are going to be looking at questions where we are going to be given concentration and we have to convert them to mole. We are going to be looking at questions where we have to deal with percentage purity and a lot of technical stuff before we then proceed into looking at enough past questions. Yes, that's going to be in another lecture video. Looking at enough past questions that relates to everything we have said. And that ends that. Do not forget, subscribe to this channel because this is where you need to be. Turn on the notification bell so that at each time we upload lectures, you can get notified and you can quickly prepare so that you meet up with your preparation, talking about time. Also do well, help your friends, help your enemies, help your boyfriends, help your girlfriends, so that together we all can move forward. From myself and the entire team here, it's bye for now.